recording? Okay, I'm gonna do this in real time. So, a person is watching a car from the top of a building. So let's say this is a triangle right here. It's a right triangle. And the top of the building would be right here. Let's label it T. And the car is traveling on a straight road directly toward the building. So let's pretend this is the road and it's traveling on this road right here directly towards the building. So it's getting closer and closer. When first noticed, so when the person up here looks at them at the first time, the angle of depression, which is this angle right here, is 22 degrees and 44 minutes. Then when the car stops, when it gets to this point right here, the angle is now 48 degrees 36 minutes. But the thing is this problem switched around the numbers. It doesn't really make sense. Like if he's looking at a tighter angle, the angle should be smaller. So these should be flipped around. But so this angle right here would be 48.6 degrees when you convert it to degrees from minutes, and then this angle would be 22.73 approximately. To convert angular minutes, each angular minute like this is 1/60th of a degree. So if it was 22 degrees and 44 minutes, it would be 22 and 44 over 60th degrees, and then you would simplify that with a calculator or something, and you would get approximately 22.73. Okay, so when the car stops, the angle of depression is 22 degrees and 44 minutes. The building is 260 feet tall. So we have this side of the triangle. How far did the car travel from when it was first noticed until it stopped? So we're not solving for this whole side. We're solving for only this section of the side where it was traveling. So first we would have to... So I labeled the distance in between the first notice and the stop as x, and the remaining distance as d. And this whole side will be x plus d. Now, since we're looking for... We're going to first look for x plus d to get the whole side. So we know the angle that's right here, and one of the sides, which is the adjacent side. So this side would be the opposite side, so we would use tangent. Then we would solve for d, or solve for, solve for d plus x, and then we would get d plus x is equal to 294.91. Now, using that, using the smaller angle. So we have two different triangles here. We have this big triangle right here, and this small triangle right here. Now, we're gonna look at just a small triangle to find d. So we would use 22.73 in tangent with the same equation, and then we would get 108.92 feet. Now, we can find what x is using d plus x. So d plus x is equal to 108.92 plus x, which is equal to 294.91. And we would just subtract, and x would be 185.99 feet.